All right, so in this video, we're going to be rotating about a different axis, and this time with shells. And here's the reason why. So if we pick our vertical one so that we could do this like this, what you notice is that it's the same function that we're subtracting from. We can't do that. It would be very complicated to sit here and separate it into two different functions and then try to subtract them and then rotate it. It's just much easier to do a horizontal. And so if we do a horizontal and we rotate it about the axis y equals -2, it's going to come down past 2 and then past 2. And what it makes is our shell. And so that is our rotation that we're going to be using here, is shells, because it is a better rectangle to use. So we need to do some little solving here. We need to first set them equal to find out our points of intersection so that we know from where to where. This is dy, and we're going to be using x equals for our rectangle. So you notice they're already both solved for x. That's perfect. And so this is the y squared plus 1. You can see it's at that point right there. So this one is here. And this one is the 2y squared. It's centered at 0. Like that. And so if you look at it as we go down the x values, it's x equals 1 is going to be bigger than x equals 0. This function is the largest. So when we get the height here, it's going to be this one minus this one. But let's first do what we were supposed to do, and that's set them equal. So 2y squared equals y squared plus 1. And then we solve. So bring everything over. In fact, on this one, we don't really need to bring it all over because it's just a square. Square root. And so we get y equals plus or minus 1. And so we need that because, again, we need to know where the y's are going to. So from -1 to +1. So again, if it says x equals, make sure they're both solved for x. We solve for y, and it'll tell us our start and our finish. So we now know our integral is going to go from -1 to 1 with respect to y. That's our thickness. Now we just need to make the volume of that shell. So the volume of our shell, the surface area here, let's call it A, is equal to 2 pi r h. And so if we go back, we can see that the height here of our shell is right here. This is our h, which is our x's. So that would be the y squared plus 1 take away 2y squared. So h equals y squared plus 1 take away 2y squared. And then we just need our radius. So our radius here would be this whole thing from here to here. And that's where the rotation comes into whatever axis we have. So right now it's at -2. So we're going to have to take this point right here. This is our y value here that we're plugging in. So that would be our y's that we plug in. And what we're going to have to do is add 2 to it. So it's y plus 2. That's our radius. So again, it's that same idea as where we're subtracting the 2, but how it affects the shells is through the radius. Okay, so now if we plug it in, we get 2 pi y plus 2, and then y squared minus y squared is -y squared, so we get 1 minus y squared, and there we have it. Now we can multiply it all out, but again, we're just going to use our calculator here, and we can plug it in and see what it gives us. So let's look what our calculator gives us. So plugging in our calculator, we get 8/3. Double check it. It's y plus 2, 1 minus y squared, -1 to 1, respect to y. So 8/3. So we have 2 pi times 8/3, which is 16/3 pi. So that would be the volume of this solid. And so let's draw our solid. All we have to do is take that exact shape and move it over here. So you can see it's 2 up, and so we just go 2 down, and then 1 unit away to there. So that and that, and so that would be our bottom. And then tracing it down to the 1, it would be that. And so you can see our shell actually did pretty decent there on hitting that. Look at that. Would be that. And so this right here would go to here, and this would go to here, and then that would go to there. So hopefully you can kind of see the solid that it would create, and it would have this kind of like hole in the middle. So it's kind of like a, what's that? Okay, here you go.